So next we are going to see about gray to binary code converter. Previously we have seen binary to gray code. Now we are going to see gray to binary. So again recalling the logic behind how to convert gray to binary. So this also we have seen in the previous chapters. For example, if you are having an output of 1 1 0 0 1, so assume this is a gray code. Okay, so now my aim was to convert this into a binary. So logic is, so this is MSP bit and this is my LSP bit. So for converting gray to binary, so first this MSP bit will be taken as it is 1. So now we have to make the XOR for this value and this value. So the result of this one and then the second bit, next bit. So XOR of 1 and 1 will give me the result of 0. Okay, now again XOR of this value and this value. So XOR of this value, that means 0, output is 0 and next bit is 0. So I am getting the output of 0. Okay, now again XOR of this value and this value. So this will give me again 0. Okay, again XOR of this value and this value, that means the this bit and just a second. Okay, so XOR of this value and this value, I am getting the output as 0. XOR of 1, I am getting on. So this is my binary value. So what is the logic here? So first MSP bit will be taken as it is. So that result value is XORed with the next nearby bit. So you will get one result. So that will be taken as, that result will be noted down. Again that result value is XORed with nearby bit. So likewise we have to do it for all the things. So this is the logic for converting gray to binary. So using this logic, we are going to utilize the 4-bit gray to binary code converters. So this is our since it is a 4-bit converter, you will be having a option of 0000 to 1111. So representation decimal value also I have represented for our identification purpose. So if I want to convert gray to binary, so what is the first logic? So G3 value, that means MSP bit. So G3 value, so MSP bit, this will be taken as it is. So the output of value of B3 is 0. Now this 0, that means B3 value is XORed with G2 value. So B3 XORed with G2, we will get what is the value? Just a second again. So this value is XORed with this value. So 0 XORed with 0 is 0. Again, this 0 is XORed with this 0. So I am getting 0. That means B2 is XORed with G1. Again, B1 I am getting 0. So B1 is XORed with G0. I am getting 0. Okay, so we will take next one. So G3 will be taken as it is 0. So next B3 XORed with G2. Okay, so I am getting 0 XORed with 0. You will be getting 0. Again, this B2 value XORed with G1. I am getting 0 XORed with 0 is 0. Now again you see B1 is 0 and G0 I have to XOR. So B1 XORed with G0, which is 0 and 1. I am getting a value of 1. Okay, so next again, we will go for another example which will be easy for you. Say, take this example. We will take this example. Okay. So first G3 value is 0. Okay. So this value is XORed with this value. So 0 XORed with 1. What is the value? 1. Okay. Again, this value is XORed with this value. So 1 XORed with 1, we will be getting value of 0. Again, this value is XORed with this value. What we will be getting? 0. 0 XORed with 0 is 0. So likewise, we have to do it for all. So our final truth table will be looking like this. Okay. So this is what our final converted truth table. So now we can again, as previously seen, we have to convert or we have to represent these outputs B0, B1, B2, and B3 in minterm format. So here I have mentioned in minterm format. So B0, B1, B2, B3, which will be helpful for my K-map drawing. So first I am starting with B0. So B0 value is this one. So how I got this? So B0 is from here, wherever the 1 is there, that will be considered as a minterm, which we already studied. So that is how the minterm has been represented here. So K-map. So when we are writing K-map, how many possible groups are there here? We will be having most of the individual groups. We can see that there is individual groups. That means we will be having a G3 XOR G2 XOR G1 XOR G0. So this is how this gray to binary works, because we are taking the previous output, so previous output, and then it is XORed with current output, current input. So likewise it is going on. So that's why it is coming like this. So B naught equal to G3, G2, G1, and G naught. Next, when we take B1, so how many pairs are there? We will be having 4 pairs. So that can be represented using like this. So this is nothing but so this expression is nothing but G3, G2, G1. So when we see previous one, okay, we can see G3, G2, G1, G0, everything is XORed for B0 value. When it comes to B1, one value is getting reduced because that is not has been find out. So B0 is the LSB bit. So this is its previous bit. That's why G0 doesn't comes here. So likewise B2, if we go for B2, we can see this is our expression, which is nothing but B3 XOR of G3 XOR of G2. Again B3 you will be having only one, which is nothing but entirely G3. So when we start drawing the graph, it will be like this. So which is XR. Okay, we can see the output has been taken as an input, the output has been taken as an input. So each bit output has been taken as an input. Okay, so this is taken as it is, and then this one will be taken in here, and this one will be taken as here. So that's all about gray to binary code converter.